All right, chemistry, this is your video lecture for chapter 8, section 1. We are talking about describing chemical reactions. First thing we're going to talk about is what is a chemical reaction? A chemical reaction occurs when two or more substances are changed into different substances. There's the key, different substances. What is a chemical equation? Well, a chemical equation represents the symbols and formulas and identities and the relative molecular and molar amounts of the reactants and the products in that chemical reaction. Things that would indicate that a chemical reaction has occurred. 1. Evolution of energy as heat and light. Something that you see in fireworks here. The fact that heat and light is being generated is an indication that a chemical reaction has taken place. Number 2, production of a gas. You see here we have two liquids that do not have any bubbles per se. There's no gas being evolved. And then as the reaction takes place, yes, gas is being evolved. There's being some sort of change. It's a chemical reaction. There's another picture. This is a common example that you may have tried at home before. Baking soda and vinegar creates a very vigorous reaction, evolution of gas. The evolution of gas bubbles when two substances are mixed is often evidence that a chemical reaction is taking place. Number 3, formation of a precipitate. A solid that is produced as a result of a chemical reaction in solution and separates from the solution is known as a precipitate. It's a solid that you put in some sort of liquid. It's in solution, but as a result of the chemical reaction, it separates out of the solution. It's no longer in the aqueous phase, and it becomes a separate part of whatever sample you're looking at. And the examples we have here, we definitely see that there are some clear liquids, and all of a sudden we have a white portion of the liquid, a yellow portion of the liquid, and on the far right we actually have solids precipitating out of the liquid phase. All right, characteristics of chemical equations. The equation must, number 1, represent known facts. Okay, you have to have some amount of empirical formula to back up your deduction about that chemical reaction and therefore your chemical equation. Number 2, the equation must contain the correct formulas for the reactants and products. Even if you know what the product or reactant is, if your formula for that reactant or product is incorrect, it's going to throw off your entire equation. Number 3, the law of conservation of mass must be satisfied. We can use coefficients to satisfy this law. Remember, a coefficient is a small whole number that appears at the front of a formula in a chemical equation. We're going to talk about word and formula equations. The word equation is an equation in which the reactants and products of a reaction are represented by words. Formula equation represents the reactants and products of a chemical reaction by their symbols and formulas. And then there's what we call a chemical equation, which essentially is the balanced formula equation. That's the big difference between a chemical equation and a formula equation, that a chemical equation is balanced. We use coefficients to allow for conservation of mass or to demonstrate that the law of conservation of mass has been satisfied. So let's look at some examples. For a word equation, we have iron 2-phosphate reacts with aluminum nitrate to produce iron 2-nitrate and aluminum phosphate. Example of formula equation, the same equation but in formula form. We have Fe3PO4 quantity 2 plus Al NO3 quantity 3 reacts to form iron NO3 quantity 2 plus AlPO4. If we're going to balance this equation to give the chemical equation, we would place coefficients in front of these different species of 1, 2, 3, and 2. Some common symbols often used in chemical equations. We have the arrow, which refers to yields. Out loud you can say reacts to form or gives, or you can simply use yields. We have parentheses S. This refers to the solid state. We have parentheses L, which refers to the liquid state. We have AQ, which refers to the aqueous state, and we have G, which refers to the gaseous state. All right, why these things are important. The coefficients of a chemical reaction indicate relative, not absolute, amounts of reactants and products. That's relative. Number 2, the relative masses of the reactants and products of a chemical reaction can be determined by the reaction's coefficients. So we'll use the coefficients to help us do those types of calculations. The reverse reaction for a chemical equation has the same relative amounts of the substances as the forward reaction. Just turn the arrow around. You'll have to balance equations for this section, and here are some rules to go by. Identify the names of the reactants and the products and write a word equation. Then write a formula equation by substituting the correct formulas for the names of the reactants and products. Then using coefficients, balance the formula equation according to the law of conservation of mass. Definitely suggest that you balance the different types of atom one at a time. First, balance the atoms of elements that appear only once on each side. Then balance polyatomic ions that appear on both sides. Balance them as single units. You don't have to break them down into their individual elements. Then balance hydrogen and oxygen after other atoms have been balanced. And lastly, count your atoms to be sure that the equation is balanced. Balancing a chemical equation. So let's start with the word equation. We have hydrogen gas reacts with chlorine gas to produce hydrogen chloride gas. We have the unbalanced formula equation here, and we'll drop a few coefficients in front of these species to make it a balanced equation. Coefficients of 1, 1, and 2. All right, let's try to have you balance these at home. So please press pause and balance the following equation. Turns out it's already balanced. Psych. Why don't you try this one? Go ahead and press pause now. You see the equation is balanced if it has a coefficient of 1, 1, and 2. Do one more. And this equation is balanced if we have coefficients of 2, 3, 3, and 2. A few more practice problems for you. Please turn the following equation into a word equation. All right, liquid carbon disulfide reacts with oxygen gas to produce carbon dioxide gas and sulfur dioxide gas. One more practice. Please press pause and turn this into a word equation. We have aqueous sodium chloride reacts with aqueous silver nitrate to yield aqueous sodium nitrate and solid silver chloride. That's the end of this set of notes. If you have any questions, please be sure to bring them to class. I will see you next period.